16. 16 is just like 15. I'm going to say y is equal to 6x squared plus x minus 1. Then we have x cubed minus 9x squared. Oh, the screen, yeah. And so what we're going to do is when they say look at the end behavior, when it says find the power function end behavior, what they really want me to do is take the limit as it approaches infinity and negative infinity. So they want me to look at this as take the limit of it. So what they really want, and we'll change this and we'll call this f of x. So what they really want is me to take the limit of f of x as x approaches infinity and the limit of f of x as x approaches negative infinity. Well, what we can do is we said that when you approach infinity and or negative infinity, the other terms don't matter. The only things we're worried about is the leading terms. And so what I could do is I could say that this limit should act like the limit of, well, what's that reduced down to? If I say 6x squared over x cubed, that's going to be 6 over x, right? If I reduce that down, can you guys see that? Is this showing on the board okay? You can see that? I can barely see it. All right, so then what would as x approaches infinity, what would be the limit of that? 0, right? So then this would be 0 if I plugged in other words, this should be like 6 over infinity, and this one would be like 6 over negative infinity, or similar to it, right? And so this should equal 0 as well. And then, so what does that how does that translate here? D. And just like before, if I were to graph this function, the function would look different, but if I were to graph this function as well, as they start to approach infinity and negative infinity, they would start to get really close together and they would be the same values. Does that make sense? Okay.